Well, welcome. In this video, we're going to look at our first section for lesson 1-1. And we're going to start out by talking about some really important vocabulary words, domain and range. These are two vocabulary words we're going to be using pretty extensively throughout this year and even in your future. So it's really important to make sure that you understand what these two vocabulary words really mean in this context of a function. So the first is domain. The domain is referring to the set of all possible inputs or x-coordinates for a function, and the range is referring to the possible outputs or y-coordinates for a function. So over here to the right, I have this little green, kind of this weird looking box type thing. This is what we're going to call a function. So what could happen is we could have an input where we're going to put something into that function. We'll call that x, and the result is our output. We'll call that y. So so we're going to be using this or referencing this function machine in the future. But in essence, that's what we're talking about. Domain is what we put into a function, and our answer, the result, is what we get our outputs. We call that the y-coordinate of a function. Now there's different ways you could represent domain and range. And one of those ways is using a verbal description, which obviously when you look at that table, it's not going to be very easy. We're not going to want to write it always out in words. Okay, that's not going to be very handy. And set builder notation. Set builder notation, well, we could use set builder notation, but it's a little bit more complicated. And to be honest, it's really not something that gets used that frequently. In reality, what gets used more frequently is this idea of interval notation. So interval notation is what I really want to make sure you understand. Now, sometimes our textbook and our assignment might have something written in set builder notation, but it's most important to understand interval notation. All right, let's start with the verbal description. So the verbal description for that first one, it says real numbers greater than or equal to 3 and less than or equal to 7. Now, personally, I like to sometimes think about what would that look like on a number line. So if we have 3 and 7, obviously there might be a bunch of other numbers, but if we have 3 and 7 on a number line, it says it's going to be all the set of numbers greater than or equal to 3. So it can include 3, and it's going to be bigger than that. And all the numbers less than or equal to 7. So here's 7, so it's going to be everything less than that. So together, it makes up those set of numbers between 3 and 7, and we're going to include 3 and 7. So how can we write that in a better way than set builder notation? Well, that would be using, like I said, interval notation. With interval notation, we're going to use parentheses and brackets, and we could use them interchangeably. And you're going to see how that works with these different examples. So we use a bracket anytime an endpoint is included. And we see that both endpoints are included here. So we're going to have two brackets, one representing the start, one representing the end. And we say, what do we start at? We're going to start at 3. We're going to end at 7. And we're including those endpoints. So again, that's why we use brackets. Let's look at the next example. Real numbers greater than 5. Now it doesn't include 5. It just says greater than 5 and less than or equal to 10. So on a number line, it just says greater than 5. So I'm going to use an open circle at 5 because we're not going to include that 0.5, but that spot at exactly 5. So we'll use an open circle at 5, and it's going to be less than or equal to 10. So that's going to be everything in between those. So we're going to have an open circle at 5 and a closed circle at 10. The way that we would represent that using interval notation is we use a parentheses anytime an endpoint is not included. So at 5, that endpoint is not included, but at 10, the endpoint is included. So we would have a bracket at 10. Now all real numbers, with the way that would look on a number line is that's everything on a number line. So everything going to negative infinity and infinity. So to the left is negative infinity, to the right is positive infinity. The way that we represent that, there are no endpoints. So we would use parentheses on both ends. We would say it goes from negative infinity to infinity. Now I'm just going to make a note over here. The way that we represent all real numbers using a letter is this kind of this weird shaped R, where we have two vertical lines there. So in interval or a set builder notation, that weird E-shaped thing, that's just saying that X is a set of all those values in the real, that are a set of real numbers. Okay, real numbers greater than -2. Now again, it doesn't say greater than or equal to -2, it just says everything greater than, so everything to the right of -2, but we're not going to include -2. So it keeps going to infinity, and that infinity is in the positive direction, so it'd be a positive infinity is to the right, negative infinity goes to the left. So it goes from -2 to infinity. And the last one here in this box, it says all real numbers less than 50. So it's going to be 50 and less than that. Now you got to be careful. We always put the smallest value first. Now there is no smallest value. That line, those set of points that we're including goes infinitely to the left towards negative infinity. So we're going to describe this to say that the lowest value is negative infinity. The highest value is at 50, but it's not included, so we would use parentheses there. So that's how we would represent those different sets of numbers using interval notation. That's going to be used pretty extensively, so I want to make sure you understand that concept because we use that to identify domain and range. Speaking of domain and range, let's look at this example. It says, what are the domain and range of that function y equals x squared minus 3? Well, even without looking at the graph, we could identify the domain pretty easily because think about it. This is my input. So what numbers can I put in there for x? I can put anything I want. There are no limits. I can put anything I want in there for x. So I could put any negative number, any positive number, any decimals. So pretty much negative infinity to infinity. So the domain would be just that, from negative infinity to infinity. Or, like I said before, you can use this fancy letter R to represent all real numbers. Or we could even use the words and say it's going to be all reals. But in reality, this first one, that's the best one to know. But any of the other ones would be acceptable. And for the range, it's helpful to look at the graph. And the graph, we're looking at the range, so the outputs, the y values. Remember, the range represents the y, the domain represents the x. And so if we look at this graph, if we look at the y values, I like to think of it as if we were to squish that graph on the y-axis, what would happen? Well, our lowest point there would be at -3, and there would be a point there at -3. And if I were to squish that graph against, inwards to that y-axis, we would get this line going up. That'd be starting at -3 and going up to infinity. So it'd start at -3 and it would go up to infinity. And we could use that same example, same thought, if we wanted to look at a graph to figure out the domain. In that case, I would squish the graph on the x-axis. If I squish this graph on the x-axis, I would get arrows going in both directions. And so in that case, again, it would be from negative infinity to infinity. So this is how we'd write it using interval notation. Now what if it's a story problem? Let's look at this next example. It says, an air tanker with a tank capacity of 8,000 gallons drops water and forest fires at a rate of 400 gallons per second until its tank is empty. What is the function and the domain and range for the function that represents the volume of water the tanker can drop in x seconds? So these can be challenging when we have a story problem. So sometimes it's helpful to think about how can we set this information up into a table. So I'm going to put this as, so we're going to use seconds as our input because that's kind of happening independently because the amount of gallons of water that's left in the tank depends on how many seconds I've gone by. So let's just think about what's going to happen here after a few seconds. So before any time's gone by, before we drop any water, there's a total of 8,000 gallons. Now, as soon as that airplane releases that water, it's going to release at 400 gallons per second. So after 1 second has gone by, that 8,000 gallons now has dropped 400 gallons to be down to 7,600 gallons of water, and then 7,200 gallons of water, and so on. Now, our goal is to figure out when is it going to be empty. So I could take that 8,000 gallons and divide it up into 400-gallon chunks. So 8,000 divided by 400 would give us 20 seconds. So it would take 20 seconds for there to be no more water left over in that tank. All right, so now let's figure out how we could represent this as a function, and then we'll identify the domain and range. And if you're not catching this, that's okay. We're going to have a whole lesson about this in the future. This is just introducing that we're going to get to. But to be able to come up with a function to represent this scenario, we're going to use function notation. So function notation looks like this. Instead of using a y, we use f or g or h. We just use a letter to represent the fact that we're working with a function. Then in parentheses, we put what the input's going to be. So our input's going to be x, or if you wanted to use s for seconds or t for time, you can use whatever variables you want. But I'll use x to keep it simple. So now let's see what was happening. We're starting with 8,000 gallons. And we're losing. So we're subtracting some water, and we're losing 400 gallons every second. So if we use x to represent seconds, this would be our function. So we'd have 8,000 minus 400 times x, or we could say negative 400x plus 8,000. But this makes more sense in the context of the problem. So now let's figure out what the domain and range would be. Now remember, our domain is our input. So our domain starts at 0 seconds, and it's going to stop releasing water because it's going to run out of water after 20 seconds. It doesn't go on infinitely. So it goes from 0 to 20. Our range, well, you might say, well, it starts with 8,000 and ends with 0, which would be true. But the way that we order this, the order is important. We always put the smallest value first. Smallest value, the least amount of gallons of water that we could have in the tank would be 0 gallons, and the most would be 8,000. Okay, so that is how we'd find the domain and the range and the function for that equation, for that scenario. All right, here's what I want you to do. They gave us a couple of functions here, and the graph is given to us. I want you to do the best you can, based on what we've learned so far, to just find the domain and range. So why don't you guys go ahead and pause the video and hit play when you're ready to check to see if you've done it correctly. All right, let's see how you did. So the domain for this one, we can put whatever we want in there for x if you look at the function, or if you look at the graph and we squish this graph on the x-axis, we'd have an arrow going in both directions. So the domain is everything. So from negative infinity to infinity. Now the range, if I were to squish this graph on the y-axis, remember we're taking all the points from both sides of the y-axis and squishing them on the y-axis. Our lowest point would be at 0, and it would be included. Okay, there is a point there where y is 0. When x is 4, y is 0. And it goes infinitely up. So it would go from 0 to infinity would be our range. Let's look at the next one. So the next one, the domain, again, is the same thing. It goes from negative infinity to infinity. And the range goes from, now remember, we always list the lowest value first. There is no lowest value. It goes infinitely downwards. So it goes from negative infinity all the way up. Now, if you said 5, that's close. I'm going to be a little bit more accurate. We'll say 4.5. And it does have a point there. Okay, there is a point where it reaches. That is included at 4.5. So we would use a bracket at 4.5. All right, so we talked about domain and range. Another couple of vocabulary words that you want to make sure that you're familiar with is this idea of x-intercepts and y-intercepts. Now, these are terms you've probably heard in the past, so hopefully you remember that the x-intercept represents where the graph of function intersects the x-axis. It's where the y-coordinate is 0. And the y-intercept, so think of it this way, it's where x is some number and y is 0 as far as the coordinate is concerned. The y-intercept is a point where the graph of a function intersects the y-axis, and this is where the x-coordinate is 0. So it'd be where x is 0 and y is some number is the y-intercept. All right, so here they give us this graph. It says a car starts a journey with a full tank of gas, and they give us the equation. Relates the number of gallons of gas, y left of the tank, to the number of miles the car has traveled, which is x. What are the x and y intercepts of the graph of this equation, and what do they represent about this situation? All right, let's start with the x-intercept. So the x-intercept here is, again, where it hits the x-axis. So that's the coordinate. Now coordinates, we always use parentheses. So it represents the coordinate where x is 320 and y is 0. That's the x-intercept. And what that means is that in 320 miles, the tank is going to be empty because x represents the number of miles traveled. The y-axis represents the amount of gas remaining. So the y-intercept, that's where it intersects the y-axis. And again, that's where x is 0, y is 16. So there's a couple ways we could phrase this. You could say after 0 miles, the tank has 16 gallons of gas. You could say the car starts with 16 gallons of gas. That's what I would say. However you want to phrase it, but that's what the y-intercept would represent. All right, we're going to skip 2b and 2c because you'll be able to use graphs for those. Let's look at this example. Identify the positive. Oh, first off, actually, before we do that, we want to identify we have we have another vocabulary word, and that's this idea of a positive interval and a negative interval. So let me grab my highlighter here. So we have positive intervals, negative intervals. Those are another two sets of terms you want to be familiar with. Positive intervals represent the x coordinates for which the function is above 0. Okay, so it's the x coordinates for where the function is going to be positive. So it's above the x-axis. The negative intervals, again, is still the x coordinates, not the y coordinates. It's the x coordinates for which the graph is going to be less than 0. So it's below the x-axis. So here's the best way I can describe this. The best way to approach this would be to draw a horizontal line on the x-axis, and above it I want you to write plus, and below it I want you to write negative. That's just going to give you a visual reminder that that is where the graph is positive and where the graph is negative. So where is the graph? Whoops. I'm going to highlight it, but we're going to identify where is this graph going to be positive and where is it going to be negative. So here's where the graph is positive. So again, we're going to describe that using the x-axis. That is really important. So it's the x coordinates where it's going to be positive. So if I were to squish that first branch on the x-axis, it would go from, so I'm just going to describe this as positive, it's going to go from negative infinity to negative 3. Now we're going to use parentheses here, because at negative 3, it's not positive or negative, it's just 0. So from negative infinity to negative 3, so the only time that we're going to use brackets is if we're dealing with domain and range. But otherwise, you can always just use parentheses. So from negative infinity to negative 3, it's positive. It's also positive on that other branch, going from positive 3 to infinity. Let's look to see where it's negative. Now it's negative at the other part. Just highlight this. There's a different color here. Let's use blue. So that's where it's going to be negative. So let's describe that, again, using interval notation, and we're describing it using the x-axis. So again, we're referring to this, we're using the x coordinates for where it's going to be negative. It's negative from when x is negative 3 to when x is positive 3. Again, we use parentheses here. We don't use brackets. All right, I know we just learned this, but I want you to give it a shot, and then we're going to be done with this first lesson. So I want you guys to draw a horizontal line. Above it is positive, below is negative. So now we're going to find the where it's positive and negative at. We're going to describe that using interval notation. And again, we describe that using the x values for where the graph is positive and the x values for where the graph is negative. So I want you to pause this video and hit play when you're ready to check to see if you did those two correctly. All right, let's see how you did. So it's positive from negative 5 to infinity. From negative 5 to infinity is where the graph is positive. Need me to highlight it to show you. I'll do that. So that part of the bar, that part of the line, starts where x is -5, and then it keeps going where x is positive, to positive infinity. Now it's negative down here. So the way that we would describe that, again, we're using the x-axis. Okay, so for what values for x would give us answers that are negative? So from negative infinity to -5. It's like at -100, the values would be negative. At -1,000,000, the y values, that graph would still be negative. At -8, it would still be negative. It'd be keep being negative until we got to -5, but then after -5, it would start to be positive. So that's how we would describe where the graph is positive and where the graph is negative.